Today we are starting Chapter 7. Today is going to be the first day of Chapter 7, and pretty much all of Chapter 7 is going to be quadrilaterals and other polygons, so multi-sided closed figures. Now the first thing we're going to really be looking at with these kind of polygons is kind of angles. Some of the angle measures. Well, we know that a triangle, the sum of the measures inside of a triangle is what? 180 degrees. And it has how many sides? Well, 3. Next one we have is a quadrilateral. And that one there is going to be 360 because we know a square has 4 right angles. So 90 plus 90 is 180 plus 90 is 270 plus 90 is 360, and it has 4. Quad. Then if we have a 5-sided figure, which is a hexagon, let's see here, no, pentagon. What do you think the sum of the measure of its angles is going to be? So we went from 180 to 360. 360 would be 2. Because how did we go from here to here? We added 180. So again, we're going to add 180, which would be exactly 540. And we have how many sides? 5, right? So we're adding 180 degrees each time. So we go to the next one, 6 sides, which would be a hexagon. Well, we would add 180 again. Yes, we keep adding 180 each time. And it works out that there's a set formula with this here. And the set formula to find the sum of the interior angles of any triangle is n minus 2 times 180. And this works for any polygon. So let's say a triangle. Well, how many sides does a triangle have? 3 minus 2 times 180. Well, 3 minus 2 is 1, and 1 times 180 is 180 degrees. We know that's true. And we can do it for any multi-sided figure. Well, here they said 6. Well, 6 would be 6 minus 2 times 180. Well, 6 minus 2 is 4. And 4 times 180 is 720. So a 6-sided figure would be 720. And really, if I want to know the sum of the interior angles of any multi-sided figure, I can use the equation n minus 2 times 180. And that will give me the sum of the interior angles. Is our equation. So looking at this first example problem, if I want to know the sum of the interior angles of this figure, well, I need to know how many sides it has. So I can just pick a starting point. I can pick, so 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides. So we can use this formula, n minus 2 times 180, and we're going to plug in 8 for n, its number of sides. 8 minus 2 times 180. Well, 8 minus 2 is 6. Now we just need to do 6 times 180. We can do that in a calculator, or we can do it by hand. 6 times 0 is 0. 6 times 8 would be 48. Carry the 4. And we would get 1080. So the sum of the measures of the interior angles of this 8-sided figure is 1080. So the sum of all these angles added together would be 1080 degrees. Any questions on any of this here? Any questions on anything we've done so far? We good with this here? Yes? Okay, let's look at another one. The coin shown in the shape is an 11-gon. Find the sum of the measure of the interior angles. So how many sides does it have? 11. So we're going to plug 11 into our formula, 11 minus 2 times 180. And at this point here, if you want to just type this in the calculator exactly as we see it, parentheses 11 minus 2, close parentheses, times 180, you can do that and it would give you the answer. Or if we did this by hand, 11 minus 2 would be 9. And then we can do 9 times 180, which is 0. Carry the 7, would be 1,620 degrees. If we typed it in and plugged this into the calculator. Any questions on any of this here? Any questions on anything we've done so far? So far we're really just plugging in the number of sides into the equation, simplifying and getting our answer. And this works with any sided figure. Would I ever get a decimal answer for this? Could we ever get a decimal for the sum of the interior angles? Well, no, because 2, if I subtract 2, I'm not going to get a decimal answer. If I'm multiplying by 180, I'm not getting a decimal answer. The only way to get a decimal is if what? The number of sides was a decimal, yes? Can I have a fraction of a side? No, it's just making it smaller. It's still one side. We can't have decimal or fractional sides. So the sum of the measures of the interior angles is always going to be a whole number. I feel we're pretty good with this here, so let's move on to the next thing. Example number 2. Now this is still using the same formula, we're just using it a little bit differently. Now they tell us the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So what is this telling us? It's telling us that if I plug however many sides into this formula here, n minus 2 times 180, it would equal what? 900 degrees. Because however many sides the polygon has, when we plug that into the formula, we should get 900. Because it told us the sum of the interior angles of a convex polygon is 900 degrees. So it's telling us that n minus 2 times 180 should equal 900. Now when we're doing this here and solving for the number of sides, the 2 steps we do will never change. The first thing we're going to do is, well, we need to solve for n. Well, the easiest thing to do first is going to be 2 divide both sides by 180. Does anything divided by itself will simplify to 1? So those 2 will simplify, leaving us with n minus 2 is equal to 900 divided by 180 is 5. And again, you don't have to do that in your head. You can do it on a calculator. You can do 900 divided by 180. Okay. What's our next step? What's our last step? Just figure out the number of sides. Do we have n by itself? No, we have n minus 2 is equal to. We need to add 2 to both sides. Because negative 2 plus 2 will be 0, giving us n by itself, and n is equal to 7. So what that tells me is that a 7-sided polygon, it will have a sum of the interior angles equal to 7. The sum of the interior angles of a 7-sided polygon is 7. And that's it. That's all we have for this here. Any questions on this here? Any questions on any of this here so far? We good with this here? Yes? Okay, let's look at another one. The sum of the measures of the interior angle of a convex polygon is 1800. Classify the polygon by the number of sides. So again, we're going to do almost the exact same thing. We'll have n minus 2 times 180. Because this here is the equation to find the sum of the interior angles. And for this one here, it's telling us it's what? 1800. So if I want to find the number of sides, I'm going to use this formula again. And I'm going to set it equal to 1800. So what do we need to do first to solve for the number of sides? We're going to divide both sides by 180. We're going to divide both sides by 180 because 180 divided by 180 will simplify down, leaving me with n minus 2 is equal to, anybody have an idea of what 1800 divided by 180 is? It is 10. Almost done. And then we have to add 2. So n is equal to 12. So if I'm wanting to know the number of sides, well, I can take the sum divided by 180 and then add 2 to it, and we'll get our answer. Questions on this here? Do we need to see another example of this? Or do we feel comfortable with finding the number of sides based on the sum of the interior angles? We're good with this here so far? Awesome. In that case, we'll move on. Because if we're getting this and understanding it, doing more is not going to make it any more clear than it already is. Okay. We want to find the value of x in the diagram. We want to solve for a missing measure. Now looking at this here, do I know what all 4 of these angles added together equal? Well, if we don't have it on the top of our head or have it memorized, how many sides does this figure have? 4. Since I know the number of sides, do I have a way to find the sum of the interior angles if I know the number of sides? It is 360, but what I could do is use the n minus 2 times 180, which for us here would be 4 minus 2 times 180. Well, 4 minus 2 is 2, and 2 times 180 is 360. So for any 4-sided figure, the sum of the interior angles will always be 360 degrees. So since that's true, it means that inside of here, x plus 108 plus 121 plus 59 degrees is equal to 360 degrees because it is a 4-sided figure. All 4-sided figures will equal 360 degrees. So this formula, the n minus 2 times 180, will tell us what the sum of the interior angles is for any multi-sided figure. Now we just need to solve for the value of x. Well, to do that, we're combine like terms first. It's going to be easiest if we combine like terms first. So we can add these 3 together. Well, 121 and 59. 1 and 9 is going to be 10, so 0 carry the 1, 5, 6, 7, 8. 180. And if we add 108 to it, we should get 288. Plus 121. 21 plus 59 is 288. So any questions on any of this so far? So we combine like terms. Now what do we need to do to get x by itself? Yep, we're going to subtract 288 from both sides, or subtract 288 from 360. And if we do that, well, these here simplify to 0. So we have x is equal to, so we're going to do 360 minus 288, 970, and we get 72 as the answer. And we can do this in a calculator, or you can do it by hand, either way. Or the way that I look at this and do this here, well, if I add 2 to 8, this first 8 here, it gives me 290. Well, if I add 770 to 290, I get 360. So I work my way back up to it. Or you can do it in a calculator and you would get the same answer. But that's it. That's all we have to do for this year. Any questions on any of this here? Feels like a little bit of geometry and a whole lot of algebra 1. Yes? So let's do this one here. Now looking at this here, well, it's going to be kind of hard to see what the sum is, but I can use my formula, and I can see how many sides I have. Well, I have 1, 2, 3, 4, 5, 6. So to find the sum, well, we can do 6 minus 2 times 180 to find out the numbers, the sum of the interior angles of this polygon. And at this point here, you can plug this into a calculator. You don't have to do this by hand, which I think is 720. So what that's telling me is that all of these angles added together will be 720 degrees. So here we'd have x plus 118 plus 111 plus 124 plus 115 plus 145. Scooch that over a little bit. Is equal to 720. Because all those angles added together is equal to 720 degrees. Now at this part, if you're don't like adding more than like 2 numbers together, especially these kind of numbers, you can just plug this into a calculator. We can add 118, 111, 124, 115, and 145 together in a calculator. And the calculator will just tell you it's 513 degrees. Questions on this here? Any questions on any of this here so far? Well, what do we need to do next? Oh, on the bag. Minus 513 from both sides. So leaves x by itself is equal to 720 minus 513 should give you 207. I want to see that again. 118 plus 111 plus 124, 15 plus 145. I didn't think that was right. That looks really big. Can anybody double check what all those numbers added together are? Yep. It should be 613. I was off. But the overall process doesn't change. It should be 107, not 207. I have a feeling when I was typing it in the calculator, I left off either probably 111 or one of them, I left a 1 out. Any questions on this here besides that calculation error? We good with this here? Okay. The measures of the interior angles of a quadrilateral are going to be x, 3x, 5x, and 7x. Well, what do I know about this sum of the interior angles of any quadrilateral? They're equal to what? 360. Any four-sided figure is always going to equal 360. So I know that all four of these angles added together will be what? 360. So we can say x plus 3x plus 5x plus 7x is equal to 360 degrees. Because again, the sum of the interior angles of any four-sided figure is 360. Find the measure of all interior angles. Okay, so we're not just finding what x is, we have to actually find out what each angle is. So let's find x first. So we can add these together because x, 3x, 5x, and 7x are all like terms. When I look at this here, well, 3x and 7x add together to be 10x. 10x plus 5x is 15x. Plus x gives me what? And you could do that in a calculator. 1 plus 3 plus 5 plus 7, which would give you 16. What would we need to do next? Divide both sides by 16, which tells me x is equal to 21. So x is equal to 22.5. Well, we already know one of the angles. One of the angles will be 22.5 because one of our angles is just x. But we have to find the others because we have to find 3x, 5x, and 7x. Well, if I want to find those, well, we know what the value of x is. It's 22.5, yes? If I want to find 3x, well, we're going to do 3 times 22.5. 5 carry the 1, 6. I believe it should be 67.5 because we're just plugging in 22.5 times 3. So that's the second angle. Well, the third angle is 5x. So 5 times 22.5. Thank you. And are we done there? No, we also have to find what? 7 times 22.5. So these here are our 4 answers. And what would I get if I added all 4 of those together? 360. They're going to add together to be 360. So on some of these here, when we're finding the interior angles, if something doesn't look right, add them all together and see, does it add up to what it's supposed to be? And here, if we did this, these would add up to be 360, and we'd be fine. Any questions on this here? Any questions on anything we've done so far? We're good with this here? Yes? Okay. Let's throw some other stuff into the mix as I write on the board. In equilateral polygons, all sides are congruent. In an equiangular polygon, all angles are congruent. In a regular polygon is a convex polygon that is both equilateral and equiangular. So if we call a polygon regular, it means all the side lengths are the same and all the angles are congruent. They're all going to be equal. So let's modify the sum of the interior angles. If I want to know one angle in a regular polygon, well, I know that n minus 2 times 180 will give me the sum of the angles, because it doesn't matter what they are or how they're all aligned. But I know in a regular polygon, they're going to all be equal, yes? And the number of angles is equal to the number of sides. So if I know that they're all equal, and I know what the sum is, if I want to find one of them, I can just take the sum of all the angles and divide it by the number of sides. So in a regular polygon, to find one angle, well, I can take the n minus 2 times 180 and divide it by the number of sides. Because in a triangle, well, we know the sum of the interior angles of a triangle is 180, yes? And we went over this last semester, but if it's equiangular, we knew all three angles inside of it had to be what? 60, right? Because we saw that we did that once. We did x plus x plus x is equal to 180, said they're all the same. Solved and found x is equal to 60. So looking at this here, well, n minus 2 times 180, the sum of the interior angles for a triangle is 180. How many sides does it have? 3. 180 divided by 3 is 60. It works. If we do it for a quadrilateral, 360 divided by 4 is 90. So this here will always give us what the angles would be if it is a regular polygon. It has all congruent sides and all congruent angles. Will this always be a whole number? Will this always be a whole number? Well, anything divided by 3, well, 3 works, but does anything divided by 9 always give us a whole number? How about 7? 11? So it doesn't always work, does it? And here, are we talking about sides or angle measures? Angle measures, right? I mean, we just had one previously that was a decimal. Angles can be decimals. Our number of sides cannot. So here, this can give us decimal answers, and it will. All right, try that again. Okay. Looking at this here, this baseball. A home plate on a baseball field is shown. Is the polygon regular? Is this regular? Why not? All angles aren't what? Congruent. Because for a polygon to be regular, all the interior angles have to be congruent. If they are not congruent, then it is not a regular polygon. So it'd be, no, all angles aren't congruent. All angles have to be congruent for it to be a regular polygon. Any questions on this here? Any questions on this here so far? Okay, well, let's go on and find the two missing angles. So I'm going to have to erase this here. So we want to find the measure of C and E. Now, I've named them X. How do I know that they're going to be the same? It says so. Because these little arc measures that it added tell us that they're congruent. Because when we have the same number of those little arcs, they're telling us that they are congruent to each other. So they're going to be the same. Do I know the measures of A, B, and D? They're 90 degrees because they have the right angle marker. So D is 90 degrees, B is 90 degrees, and A is 90 degrees. So far I have X plus 90 plus 90 plus 90 is equal to what? Well, it didn't tell us that, did it? Well, not directly. Do you have a way to find out what the sum of the interior angles of this figure is? What? How many sides does it have? 1, 2, 3, 4. Because n to minus 2 times 180 will always give us the sum of the interior angles of any polygon. And if we do this here, it'd be 3 times 180, which is 540 degrees. So the sum of the interior angles for the baseball diamond is 540 degrees. This is a 5-sided figure, so all the angles inside the polygon will add up to be 540. And let's solve. Well, x plus x is 2x. 90 plus 90 plus 90, well, 90 plus 90 is 180. 180 plus 90 is 270. All right, what do we need to do next? We need to we're going to subtract 270 from both sides. Well, 270 minus 270 will simplify out, leaving us with just 2x is equal to, well, 540 minus 270 will be 270, isn't it? And last but not least, we need to divide both sides by 2. And when we divide 270 by 2, we get 135. And that's another reason we know that this is not regular, because angles C and D are not 90 degrees. Because for them to be a regular polygon, for this to be a regular polygon, all of them would have to be 90. And that's it. That's all we have to do for this here. Any questions on any of this here? How do we feel with this so far? Feel pretty good with this here? Yes? Okay. I don't feel like that's any different than what we just had. Using exterior angles of a polygon. Okay, I'm going to have you watch this. You don't have to fill this in because it's a little bit tricky to try to fill this in. Using exterior angle measures of a polygon. So we have this here. We have this shape here, yes? And y'all can see the different exterior angles are colored. We have 1, 2, 3, 4, 5. Those are the exterior angles, yes? Can I change the size of the shape without changing the angles? Because I can make it bigger or smaller, yes? So what I'm going to do is I'm going to shrink the shape. Or really, they're going to cut out the angles. And if I put those together, what we get is 360. So the sum of the exterior angles is 360 degrees. Okay? You okay with that so far? Okay. So the sum of the measure of the exterior angle of a convex polygon, one angle at each vertex is 360 degrees. Okay, that's cool. So what's the sum of the exterior angles of a dodecagon? Sum of the exterior angles of a dodecagon. What is the sum of the exterior angles of a dodecagon? What do y'all think? How about a hexagon? How about a nonagon? So it's, how about a chilagon? The sum of the exterior angles of a polygon is 360. Now, say I wanted to find one exterior angle of a regular polygon. What do you think we can do? Well, the sum is 360, and I would divide it by what? The number of sides. So for a dodecagon, well, the number of exterior, or the number of sides for a dodecagon is 12. So if I wanted to find one angle in a regular dodecagon, well, I can take 316 and divide it by 12. And 360 divided by 12 is going to be 30. Because to find one of them, we can do 360 divided by n. That's not bad. We can do it with all of them. We just divide it by the number of sides. Any questions on this here? Any questions on any of this here so far? I actually want to look at something kind of interesting. I'm going to erase these here for a second. You don't have to erase these. Because a dodecagon, if I want to know the interior angles, well, I would do 12 minus 2 times 180 divided by 12. I want to know one interior angle, one of the interior angles of a regular dodecagon. So we can use this here. Well, 12 minus 2 is going to be 10. 12 minus 2 is going to be 10. Now 10 times 180 is going to be 1800. Now if we do this here, and we do it in a calculator, we will get 150 degrees. So in a dodecagon, a regular dodecagon, each interior angle is going to be 150 degrees. So the interior angle was 150. The exterior angle was 30. What do you notice is special about those two numbers? They add up to 180. They make a straight line. And it will always work out that way. Next page. Because if you notice this here, 2x is an exterior angle. It and the interior angle right next to it do make a straight line, yes? So the sum of the exterior angles, or one exterior angle, and one of the interior angles of a regular polygon will always add up to be 180. It will always work out that way. That's kind of nice. I find that kind of interesting. All right. We have a little bit more, and then we are done for today. But we're going to look at these here. We're going to solve for the value of x, solve for the missing angles. Right here we're just solving for the value of x. What do I know about these four angles? They add up to be what? 360, because the sum of the exterior angles is 360. The sum of the exterior angles is 360. So 2x plus 67 plus 89 is 360. The sum of the exterior angles of any polygon is 360 degrees. Well, 2x plus x gives me 3x. Now we have to add 67 and 89 together. Which I believe will give us 156. And we get this here. Any questions on this here so far? So what do we need to do next? We need to get x by itself, and we can do that by subtracting 156 from both sides. I want to say 204. All right, and then we would divide it by 3. Which would tell us x is equal to 60, what? 6, oh, that's nice. And that's the value of x. And that's all it's asking for. It didn't ask for each exterior angle, it just asked for the value of x. So again, when you're doing the homework problems or working on these, make sure to read the directions and see what it's asking for. Is it asking for the value of x, or is it asking for the angles? Because on the quadrilateral we did earlier, it asked for the angles, not the value of x. So be careful on what it's asking for. But that's it. That's all we have to do for this here. Questions on this here? Any questions on any of this here? We'll do one more. We'll do at least one more. Find the value of x in the diagram. What do we know about all these angles here? They add up to be 360. So 5x plus 62 plus 35 plus 69 plus 41 plus 58 is 360. I'm going to write it on the other side because I ran out of room. Because the sum of the exterior angles of any polygon adds up to be 360. Now at this point here, we need to add all of these together. Thank you. Well, we need to get x by itself, so I would subtract 268 from both sides. $92. And our last step would be 2. Divide both sides by 5. And we are not going to get a whole number answer for this here. So that's it there. Any questions on any of this here? Any questions on anything we've done so far? We good with this here? Okay. I feel like y'all have gotten pretty comfortable with this here. Now, this is going to be the last step and kind of last thing we look at, because I'm wanting to apply what we've had already, the regular dodecagon. So, well, this here we've actually done this. Because if I want to find one interior angle in a regular polygon, we're going to use our n minus 2 times 180 divided by n. So we just plug in the value for n. So if I'm wanting to find one angle in a regular polygon, we're using this formula, this n minus 2 times 180 divided by the number of sides. Does anybody remember what this was? So 150. Because we did this a minute ago, or you can plug it into the calculator. So you can do the fraction key n minus 2 times 180 over 12. And we get this here. Now to find the measure of each exterior angle, well, the sum is what? 360 degrees. Since it's a 12-sided figure, it will have 12 exterior angles. And we get this here. Hold on one second. So this here is all we need to do. And this works for any multi-sided figure. We just use these two formulas to find the sum, or find one regular exterior angle or one regular interior angle. And that's all we